motion. So, what is circular motion? Suppose there is a circular path. There is a circle, and of course, then there will be what? There will be a center. There will be a center, and a particle. Suppose at A is moving along the circumference, and in a time interval, suppose T, it moves to B. So while moving from A to B, you're taking time T. And at that time, what actually you are doing, you're making an angle at the center. You're describing a angle at the center. So let it be what? Theta. Now, in that time interval T, that means you're making an angle what? Theta at the center. Okay. So it's similar to your linear motion. So in linear motion, actually, in a particular time t, you will travel a distance s. So if you divide s by t, then you will have velocity. So exactly similar to this, here also you will have a velocity which is almost similar to your linear velocity, but here it will be known as what? It will be known as angular velocity. It is known as angular velocity, and it will be represented by omega. So similar to s by t, here it will be what? It will be theta divided by t. And theta, so it will be equal to what? Radian per second. Okay. So theta, in your linear motion, s may be what? Distance or displacement. So likewise, in circular motion, your theta, it can be named as angular displacement. Angular displacement. Angular displacement. Okay. So, now we are having what? So from angular displacement, we are having angular velocity, and in the same way, we can have angular acceleration. Angular acceleration, exactly similar to your linear acceleration, and that is what? V by t is equal to what? Linear acceleration. So here also the angular acceleration will be equal to what? It will be symbolized by what? Symbolized by alpha, and that is what? Omega divided by t. So it will be what? Radian per second square. So in circular motion, first of all, you have to know angular displacement. You have to know what is theta, that is called angular displacement. Then you have to know angular velocity, and then you have to know angular displacement. They are more or less similar to your what? Distance or displacement, velocity, and what? Acceleration. Okay, now I have used the word displacement, which is normally a vector quantity. So my question is theta a vector quantity? So this theta is actually what? Is it a vector quantity? Is it a vector quantity, or is it a scalar quantity? Okay, so to know that, actually, now let us consider a plane. Let us consider a plane like this. Okay, now in this plane, so this is a plane, and in that plane, a particle is suppose undergoing a circular motion, So definitely there must be what? There must be a axis of rotation. So this is the axis of rotation. Okay. Now suppose this is the particle at A, and he is moving to what? He is moving to B, and in the process, he is making an angle what? You will join like this, so you will have a what? You will have an angle theta in clock or anti-clockwise direction. In anti-clockwise direction because they are moving from A to B in anti-clockwise direction. So that means that rotation will be given by whom? What will be given by what? Will be given by theta. So the direction of theta will be what? Along the axis of rotation. Similarly, if you are moving from B to A in clockwise direction, then direction will be theta will be what? Vertically downward. And what is omega? Theta by t. So this will also be what? Direction of your omega vector, angular velocity vector, and what? Angular acceleration factor. So above all, actually, what we can conclude that this can be considered as a what? This can be considered as a what? Vector. And if it is a vector, it should have direction. And direction will be what? Direction will be perpendicularly to the plane of rotation. Perpendicularly to the plane of rotation and what? Along the axis. So again we repeat that in circular motion, to know circular motion you have to know some new quantity. One is called angular displacement, then angular velocity, then angular acceleration. And they are in reality they are actually known as what? They are known as what? Vector quantity. And if they are vectors, so they should have direction, and their direction will be what? The direction will be what? Perpendicular to the plane of rotation, perpendicular to the plane of rotation, and along the axis of rotation.